welcome to Intro to Probability with Mac,
Lance,
Lucci, and friends.
Hi, friends.
Okay,
Hi.
making a big assumption there. It's a probability that they'll get any other friends. All right, intro to probability. We've got a lot of words here in this video, so go ahead and pause it right from the start and copy down all of these words, and then we'll talk about it. Freeze and pause. Okay, let's talk about it. Two kinds of probability. Experimental probability is what happens when you actually do something, when you actually conduct an experiment. So for example, if I roll a die 6 times and I want to count how many times do I get a 2. That's experimental probability. If I roll 6 times and I count up, oh look, a 2 happened 3 times. That's experimental probability. Theoretical probability is what we expect will happen in the future should we continue to roll. So, for example, if I roll a die 6 times and I get 3 2s, well, then my experimental probability is 50%. But I know that's not the theoretical probability. How many times should I expect to have a 2 come whenever I roll a die? 1 time out of every 6, right? So if I increase the number of trials, if I do it 50 times, if I do it 100 times, then I do it 200 times, then 500 times, and 1,000 times, that probability is going to change from 50%, getting closer and closer and closer to being 1/6, or 16%. The experimental probability will approach the theoretical probability if you do it enough times. So that's the difference. When we're doing calculations, we're doing a calculation of what we think is going to happen in the future. It's always a theoretical probability. If we do something and we flip a coin or spin a spinner or something like that, and then see what happened from it, that's an experimental probability. The outcomes are just the number of things, or not the number of things, the things that could happen. If I flip a coin, the outcomes are heads or tails. If I roll a die, it's 1, 2, 3, 4, 5, or 6. Frequency is the number of times that our thing is observed. So if I roll 6 times and 2 comes up 3 times, we would say the frequency of 2s is 3, because it happened 3 times. But the relative frequency is we rolled 6 times and we got 3 2s, so 3 out of 6 is 50% would be the relative frequency. We're always talking about a percentage of the total with relative. Okay, so let's look at an example. You can pause if you need again to write down this. And actually, go ahead and try this on your own. See if you can fill in these blanks. And then restart the video and see if you got them right. And start. We're tossing this plastic cone up into the air and seeing how it lands. If it's going to stick and land on its base or if it's going to land on its side. Our number of trials means how many times are we going to throw this thing. And that is 300. We have 2 possible outcomes. It could land on its side, or it could land on the base. Those are the 2 possible things that could happen when I throw it in the air. It's not going to land on its peak if it's not muddy. Frequency of the side. How many times did it actually land on its side? 203. How many times did it actually land on its base? Well, out of the 300, we just need to subtract, and that would be 97. So the relative frequency would be it landed on its side 203 out of the 300 times, or roughly 67% is the relative frequency. And it landed on its base 97 out of 300 times, which is about, this would be about 33%, roughly, if you do a decimal and round it. Is this experimental or theoretical? Well, we actually did throw this thing 300 times. So it's experimental. Okay, you should be able to get these right and just understand what these words are as we're talking about these words. Okay, in the next screen, this is an experimental. Situation. You do not need to copy down this data and this chart and all these kinds of things. All I want you to do on this is I want you to examine this for a moment, pause the video, and try to answer the questions. Try to answer 1, 2, and 3 just by looking at the data that's here on the screen. So pause it and try 1, 2, and 3, and then restart it. Pause. I need a calculator from somebody. Okay, now to answer this, we've got cars that are imported into Australia in 2005 and 2006, and here are the countries that they come from. You see Japan is sending Australia the most cars, right? They're making the most France probably the smallest. And here's our totals. So if a car was imported in 2005 and it was in a crash, what's the probability it came from Korea? Let's see what you got. The 2005 Korea cars are 23,842 out of, and this is the question, what should be my total? If the information is that it comes from 2005, then we need to use the total from 2005. So out of the 283,863 cars in 2005, this is the number that were from Korea. So the percentage, the probability that it came from Korea is, calculator helper?
8%.
8%. Probably 0.08, and you can make it 8%. Check your work, see if you did that correct. If you're sitting here, you can try these kind of on your own and see if you get it right. Okay, how about the ones from Germany? Well, Germany is going to be this 11,455, again out of the total from 2005. Calculator help?
4%.
4%. So very small chance that that car was from Germany. Probably it was from Japan. Jason's car was imported in 2006. What's the chance it came from the USA? Well, we look at the USA cars in 2006. There were 10,412 out of the 317,267, and that percentage is 3%. Thank you. Probably 0.03 as a decimal. Okay, now this is experimental probability because they already have the data. They already recorded what happened. Now we're just looking at what was the probability for something that has already happened. We're not predicting the future necessarily with it. Sarah's car was imported in either 2005 or 2006. What's the probability it was imported in 2005? Okay, well, how many 2005 cars? There were these 283,863 out of the total of 2005 plus 2006. I need calculator help for this, to take the total here plus the total here to give me the overall total. Looks like it's going to be a little bit around 600,000. 601,130. So as a percentage then, the probability that her car came from 2005 looks like a little bit under 50%. 47%. Okay, good. And what's the percentage that it came from the United Kingdom? Well, how many total cars were there from the United Kingdom? 13,000 here and 16,000 here. So calculator help, can we add those two numbers up? That's probably going to be around 30,000. 30,281 out of, again, the total, 601. Out of all these cars, how many were from the United Kingdom? 5%. 5%. So only 5% of the cars came from the UK. So we're looking at data and being able to calculate experimental probability. All right, the last thing here, the idea here, and for you guys need to jot this down too, is sample space. You should start writing again here. Sample space is a very common word when we're talking about probability, and sample space just represents the set of all the possible outcomes. We talked about what an outcome is. The sample space is the set of all of them, all the things that can happen, listing them. We could list them. Actually, we could actually draw a grid also that would show like a chart. We could also use a tree diagram. You've probably done these in middle school. And a Venn diagram, which is the thing with the circles. 4 different ways that we can show or represent sample space. So here's an example. I'm going to go fast, even if you guys just kind of catch up as you can. You can pause and write if you need. Listing the sample space for choosing a number between 1 and 9. Okay, well, so basically it's saying, what are the possible outcomes if I'm picking a number between 1 and 9? Well, 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9. No, not 9, because they got to be between 1 and 9. And the way that we write this is using a set notation. So we do a squiggly here and a squiggly there. Set notation. It's listing the possible outcomes. List, again, because it's asking me to list. List the possible results when A plays B in 2 sets of tennis. Well, what could happen? Either A could win and A could win, or B could win and B could win, Or A could win the first and B wins the second. Or B wins the first and A wins the second. There are 4 outcomes in the sample space if the two are playing each other twice. The results of a dime, a quarter, and a nickel. That's if I'm flipping them. I should have written if you're flipping a dime, flipping a quarter, flipping a nickel, what could happen? Well, we could have the dime could be heads, the quarter could be heads, the nickel could be heads. Or the dime could be heads, the quarter could be heads, and the nickel could be tails. We could have heads, tails, heads, or heads, tails, tails. Or maybe the dime is tails, so we got tails, heads, heads. Notice I'm kind of organizing this so I'm repeating them. Tails, heads, tails, 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 heads, or tails, tails, tails. See the way I kind of organize this was thinking they're all heads. What if the last one changes? And then what if the middle one changes? Then we'd have 2 possibilities, the heads or tails on the last one. And then here I just changed this, but I kept these 2 the same. It's a way to think about it. So there are 8 possible outcomes, basically because there are 2 outcomes, heads or tails, and we've got the dime, the quarter, and the nickel, which means there are 8 possible outcomes for this event. The last question here is to use a grid to show, a 2-dimensional grid to show the sample space for tossing the coins at the same time. So we've got coin 1, coin 2. The possibilities here, the outcomes are heads or tails. The possibilities here are heads or tails. So we can just make a little chart. It could be heads, heads. It could be heads, tails. It could be tails, heads, or it could be tails, tails. This is another way to represent the sample space. There are 4 possible outcomes. And then list them in set notation. Well, this is heads, 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 tails, tails, heads, tails, tails. Just different ways to write the sample space. Intro to probability. Have a great day.